This lesson we're going to be looking at exothermic and endothermic reactions. So the first part of the lesson we're going to explore the difference between exothermic and endothermic reactions. So what are we looking at in terms of energy and how that energy is being transferred? And then for the second part of the lesson, you're going to plan an investigation into the energy changes in chemical reactions. So I'm going to ask you to plan a certain investigation and submit that back to me on Teams. Now, when we talk about energy changes in chemical reactions, this is very similar to the concept in physics when we talk about the conservation of energy. What we say is that whenever a chemical reaction takes place, energy is always transferred. So, can we write this first opening statement down? Whenever chemical reactions take place, energy is always transferred. Okay, so energy is always transferred whenever a chemical reaction takes place. Now, if I'm saying energy is always transferred, I want you to now on Teams type back to me what this actually means. What am I actually saying? When I say energy is always transferred, I'm saying in another way that energy cannot be two things. And you would have come across this in physics. So I want you to be able to tell me that on Teams. So I'll repeat again. I'm stating here, whenever chemical reactions take place, energy is always transferred. So what does this essentially mean? And there are 2 points to it. And I want you to type the answer back to me on Teams. So we have total energy here. There's a clue there. Total energy as a subtitle. And the opening statement says, whenever chemical reactions take place, energy is always transferred. What does that mean? And I want 2 points, 2 answers for this to explain what that sentence means in terms of energy. So can you pause the video here and can you type your answers back? Okay, so what you should have got is that energy cannot be created or destroyed in any chemical reaction, and this is important. So what we are essentially saying is that energy cannot be created or destroyed in any chemical reaction. This means that the total energy is constant in the chemical reaction itself. Now, what happens in a chemical reaction for this transfer of energy is simply that chemical bonds in the reactants are broken and new chemical bonds are made in the products. So this is essentially what is happening in terms of a chemical reaction and causing this transfer of energy. So now let us put this in terms of bonds being formed and bonds being broken. So what we say, that when energy is transferred, chemical bonds in the reactants are broken. So chemical bonds in the reactants are broken. So this is our first point here. So chemical bonds in the reactants are broken, while chemical bonds in the products are formed. All of this, so bonds being broken and bonds being formed, all of this results in energy transfer. So this is essentially how energy is it's not really created or destroyed in a chemical reaction. Rather, the breaking of bonds and the forming of bonds results in energy transfer, and this is what we call as energy change in a chemical reaction. And now we need to look at how we classify this energy change, i.e. exothermic or endothermic. Now we're going to look at exothermic reactions, and we're just going to summarize exothermic reactions into a few bullet points. So the first one is that they transfer energy from reacting chemicals to their surroundings. Notice I've underlined the word reacting. So the reactants, when they start to interact, they transfer energy to their surroundings. So this is a classic example of an exothermic reaction. It transfers energy to the surroundings. As a result of this energy being transferred to the surroundings heat up. So it heats up the surroundings. Exothermic reactions heat up the surroundings. A rise in temperature can be measured as the reaction happens. So if you follow this logically through, if you're heating up the surroundings, therefore you can detect this temperature change as a rise in temperature. Okay, as the reaction proceeds, you can detect that an exothermic reaction is happening by measuring the rise in temperature. Products of exothermic reactions have a lower energy content than the reactants. Now, what this is saying, this will become more clearer in the next lesson when we look at in 2 lessons from now, when we look at energy profile diagrams. And what you'll see there is the energy of the products and reactants can be represented in a different way based on if it's endothermic or exothermic. Now, the description of this is that products of exothermic reactions have a lower energy content than the reactants. Okay, so can you just take that statement down in terms of the energy content of products and reactants? When we have an exothermic reaction, the energy content of the products is lower than the energy content of the reactants. And the last point is that we represent the units for this energy transfer as kilojoules per mole. So kilojoules per mole is the units. Now, what I want you to do is, on a Word document, I would like you to research and find 5 examples of exothermic reactions and give a brief description of them. So your task right now is to find 5 examples of exothermic reactions and give a brief description of each of those exothermic reactions, no more than 3 sentences. So I'll repeat again. Can you pause the video here once you've taken the notes down here? So look at this brief description of an exothermic reaction. And what I want you to do is find 5 examples of exothermic reactions with a brief description explaining to me why this is an exothermic reaction. It can be anything. It can be organic, it can be inorganic, it can be a living organism. So you find 5 examples of exothermic reactions, and for each one, a brief sentence, no more than 3 sentences, explaining why this is an exothermic reaction, and try and fit some of these points into your examples. For endothermic reactions, here are the summary points. Energy transfer from the surroundings to the reacting chemicals. So you've got energy that's taken from the surroundings and supplied to the reacting chemicals. Because energy is taken from the surroundings, you get a fall in surrounding temperature. So the surrounding temperature falls. And generally, if you were to, let's say, have this reaction happening on the surface of your skin, you would feel a cooling sensation. Whereas if you were to have an exothermic reaction happening on the surface of your skin, you would feel a warming sensation. So in endothermic reactions, because there's a fall in surrounding temperature, there's a cooling sensation if you were to able to feel this. And therefore, if you were to measure this via a thermometer, you would be looking for a decrease in temperature from the surroundings. Okay, now products, in terms of energy, the products have a higher energy content than reactants. Notice this is the opposite of exothermic reactions, where the products had a lower energy content than the reactants. So in endothermic reactions, the products have a higher energy content than the reactants. Now, as you completed for exothermic reactions, some examples for endothermic reactions, I want you to find 3 types of endothermic reactions. Now, generally, endothermic reactions are less common than exothermic reactions. However, I want you to try and find 3 endothermic reactions and have a brief description about each one, and upload your answers back to me on Teams. So do the same procedure as you have completed for exothermic reactions. Now do it for endothermic reactions. Limit it to 3 examples and just a couple of sentences explaining why this is an endothermic reaction. So pause the video here, and can you complete that task and upload your answers back on Teams. So for this task, it's only 10 minutes. I want you to complete this on a Word document and upload the solutions back to me on Teams. So you've got here 3 questions. You don't need to write the questions out, but you must write in full sentences. And can you correctly label your questions on your Word document when you do upload the solutions back to me on Teams? So now can you take 10 minutes and can you work through these questions and upload your solutions back to me on Teams? Once you've uploaded your solutions to the questions for the previous task, what I want you to do now is, using the resource link that I will provide to you on Teams, can you plan an investigation to explore the energy changes involving at least one solution? So your reactants must be in a solution state. At least one of the reactants must be in a solution state. Both can be, if you can find the reaction that is either exothermic or endothermic. So what you're going to do is, on the link that I will provide you, I want you to go through that resource link, look at the various reactants and products that are being mentioned and talked about. Using that resource link, I want you to plan an investigation where one of the reactants is in a solution state. It may be in an aqueous state, most likely will be in an aqueous state. And I want you to plan an investigation to explore whether the reaction is exothermic or endothermic. And even if you know it's exothermic or endothermic, what steps would you take to prove it's exothermic or endothermic? You can look at it in another way. So I'll repeat again. You're going to use the resource link provided on Teams, and you're going to, after going through the information, you are going to plan an investigation which will show that the reaction is either exothermic or endothermic. So you're going to have to think about the materials that you're going to use, the apparatus that you're going to use, and the procedure. And you're just going to give a quick bullet point and a bullet point outline of this plan of the investigation, where you're going to prove if a chemical reaction is exothermic or endothermic. Can you do this on a Word document? And once you've completed that, can you upload your work back to me on Teams?